You scared yet? AI is accelerating, folks. It is accelerating. Are you scared yet? Every new release of an LLM that's like crazy, and it gets crazier and crazier and crazier, I'm like, are you ready? Are you ready yet? Today, we're going to review this press release. We're not actually going to review, just as a side note, we're not going to inference the LLM right now. I'll do another stream where I build something with the AI. Maybe I rebuild something I already made with it just to see if it's more powerful. But today we're just going to look at the tech. Um, and are you scared yet? Because it's getting interesting. Because so far, Llama 3, based on what they're saying, within months is already better at 8 billion parameters as their 70 billion parameter model that they released like months ago, or within the year. So I think that's pretty crazy. I think that's pretty crazy. All right. So also, yeah, I'm in a different situation right now. This is not my normal setup. This is it's not. It's a bit of a janky setup today. I'll be honest. I hope you guys can even hear me right now. Let me. I forgot to post. Forgot to post this. Okay. All right. Let's do it. Okay, a little background, a little background. Well, let me actually write it out. Sorry, it's not. Ignore this. Actually, let me open up a different thing that isn't. Sometimes I'll open up code that's like not mine, or it's mine, but it isn't. All right. So let's go through like what happened this past year or so. So first, actually, let's just go to the beginning. Let's make a little timeline. See if I can remember. I'll at least include when I started streaming. So let's go. What happened this past year or so? Okay, so first, ChatGPT. I understand it was a little bit more than a year. ChatGPT comes out, and the average person is 10x now. Dude, have you tried Grok? I just learned about it so fast. Yeah, I've tried Grok. Let me get in the whole fucking. Should I do a stream where I compare all the LLM services? Because I build with a. Dude, I've been building a lot of stuff with LLM agents. Not just the fine tuning stuff. Like at this point, I figured out some pretty cool stuff, and I'll share. I've figured out some pretty cool stuff when it comes to actually like building LLM agents and not having to do it overkill. And I'm going to show you guys real soon. Uh, I figured out some cool stuff. I want to show you guys that, but I also want to compare a lot of the servers because really, I know we want to keep things internal, and everyone wants to, um, own everything. But a lot of these cloud providers are getting very good, and you always have to do the best thing. Get your ego out of it. All right. Anyway, let's get back to it. What happened this past year? First, ChatGPT comes out, and the average person is 10x now. What I mean by that is the average person has access to. I know it wasn't. It was like about a year and a half. I don't know. Access to general intel. You know, pretty good general intelligence that can do stuff for them. Code, right? Okay, so that's like the first thing that happens, and then I was wondering. I don't know if it's like ever too big or small. Or I don't know. Okay, so the next thing is we start having a fleet. Hold on a second. We have a fleet of open source followers, and I'm not saying that. And let's list them out. I'm not saying followers in a bad way. I'm not saying it in a bad way at all. Um, just gonna say that for now. Let's actually um we don't I'm not gonna disagree. It's not I'm not gonna say stability is a follower at all, but they're not. They're a part of this. Let's see. Okay. But let's just say Mistral, Meta, Google, yada yada. So there's a lot of people start building and training using this new crazy, which it's been done for many many years before this. But I'm just talking about a consumer timeline. Many people have been making their own open source versions of LLMs, right? So they've been making things like, hold on a sec, let me make this full screen. So they've been making things that fine tuning on a lot of data models that can perform very almost as good as GPT-4. And now we're actually getting a little bit better than GPT-4. And Meta is king in open source right now. So right now, when it comes to these open source LLMs, Meta is actually like the best, in my opinion. In my opinion, they don't pay me. Okay, they actually keep contacting me to work there. That's true. It's not like a flex, but I don't want to do it really personally because it sounds like a drain. But and I have my own stuff going on. But they want to pay me. But hey, they don't pay me. But I will say Meta is actually like the best right now when it comes. And Llama, I've built LM agents with a ton, Llama 2 a ton. Code Llama is great at coding. Let me just give an overview of where we're at right now. So they came out with Llama, then Llama 2, Code Llama, and now we're at Llama 3. These are like they've done a lot. Okay, they do a lot when it comes to LLMs, and they do a lot, especially like the image segmentation. I mean, there's a ton of things they've been doing AI in the open source for like about a decade. Okay, so I'm not like going to cover everything. I know people are going to be like, "Oh no, they did this." I get it. Code Llama is great at coding, but it generally sucks because of the guardrails. It's just a little overview. Llama 2 is no longer relevant because of, and guys, you've been seeing on the streams, I've been experimenting with this technology a lot and I know about it a lot. Okay. For a general software engineer who's not like actually a machine learning engineer, listen, I know a lot and I can tell you Llama 2 has not been relevant for a bit, right? But we've been waiting on Llama 3, and that's mostly because of one particular thing. Llama is trained in an interesting way. Okay. So this is why Llama excites me, is because it's the token size, the feature space that it's in which it is trained on is way bigger than anything else, but it's a very small model. So you have a model that's the parameter size. So if you see it as like, look at an AI model as like a bunch of as a, I guess I'm not literally going to say neurons because like if I'm going to dumb it down, I should dumb it down. See it as almost like a bunch of gates to enter a city or something, like a bunch of tolls. And every time you toll, they learn a little bit about you. And every time a person goes to the toll, that specific toll will learn a little bit about that person. And let's say every person that comes to the toll to the city, they learn a little bit more about what type of person goes to the city. And they take a picture of your face, they look at your car, they look at all these different dimensions and all that. Now, uh, what Llama is doing is actually they're putting not just more cars through, but more different types of cars and people, more than pretty much anyone can when it comes to passing these cars through the tolls, and it's because of their access to data. Okay, so does that make sense? Is anyone confused? Hey, what's up, Florian, in the chat? By the way, yeah, I got a different setup today. Okay, it's a little different. I'm gonna have a bit of a different setup. By the way, and in like an hour, I'm gonna be streaming resume reviews with Nate. Um, Nate, I'll post his channel. I'll post it. Already posted his channel in Discord. Yeah. Okay. So understand it's not. And by the way, when I'm saying it's not just the data set size. I mean, it is that they have a lot of data, but it's the feature space. That's where a lot of the advantage with Llama has been. And when I see what they do with Llama, I see their interest in looking at what type of energy they're passing through this model and how they can retain as much interesting information. When we're talking about entropy, we're talking about information, and entropy is how these models are trained. We're talking about gathering information from these data sets going through the model and with a big feature space. What we're talking about is a lot of energy. And these models, and I can post an interview from Mark Zuckerberg, and he did recently that's very good. Highly suggest you watch, where he talks a lot about energy. Uh, and I can see that that's something they're very interested in. Okay, cool. So, hey, what's up? Hey, what's up, NP Mail? Yeah, in the chat, go follow NP Mail. I don't know if I'm saying that right. Um, but Nate, we're gonna do a stream in like an hour. All right. So let's review. Let's first. Okay, so I'm not gonna go through the takeaways because that's like. Let's just break it down. Let's break it down. All right. So they released. Uh, when did they? Before we do this, let me actually look through. When did they release Llama 2? Let's see. In July. So that's like not even a year. That's crazy. It's not even a year. Okay, that was like right when that was the month I thought I started streaming. I think. Wow. Cool. So they released an 88 billion and 70 billion parameter model. Just to give you context, before they were releasing 7 billion and 70 billion. Now they also have an 400 billion parameter model that I believe will be open source. That's under the Llama brand, I guess. And I don't think they released that, but that's supposedly going to outperform. I think mostly everything commercially, or I don't know. I don't know. Anyway, so let's look at. By the way, I'm going to go through a lot of what this means, but here are the benchmarks. We're going to go through each of these benchmarks and what they mean in a little bit. But first, let's go through these benchmarks. Are these benchmarks like they should have a benchmark here that just says 10? Like, is it 10x? Like, can it? That's the human eval one. Can it code? That's what I care about. I'm like, can it code? So here's another thing, just to cover a little bit about what Mark Zuckerberg said. Maybe I should like actually clip stuff. I should clip when he said this. He mentioned something very interesting in his interview. Highly suggest if you're interested in the future of this space to listen to it, because he mentioned they learned early, like probably a couple years ago or a few years ago, that when you're training LLMs, no matter what, training it to learn reasoning, to learn how to code. So teaching it how to code and teaching it the reasoning capabilities that it'll need in order to code, which probably has to do with generating a data set that involves reasoning. I mean, I don't know. I don't know particularly what they're doing, but I'm guessing it has to do with that. Maybe some DPO, like what I was talking about. Definitely RLHF. But they're doing something to sort of like have it align or converge to something that is very competent at reasoning. And teaching it to code, no matter what the task is actually very good at increasing these numbers, which are benchmarks for reasoning. So whether it's an LLM that is supposed to do that, that's the downstream task or not, that appears to be something that's very valuable. And we can think about what that means, right? Um, John Hartway, Nate forced me to come here. Hey, what's up? Oh, Nate's bringing people here. Yo, what's up, everybody? Hello, I'm here from Nate's stream. He forced me at gunpoint to come watch his stream. Good, good, good. Nate has the fact that Nate forced you at gunpoint means I can trust him. Mark said that Llama 3, 8 billion was almost as good as Llama 2, 70 billion. Yeah, yeah. I'm pretty sure he said it was better. Let me verify that. By the way, everyone in the chat right now, Florian included, they've all been whipped, okay? No one here is here by choice. So the fact you're here by gunpoint is a good thing. You belong here, okay? Black guy whipping people. All right. You know, talk about whipping a lot. Maybe that says something about me. Okay. So, so the so here they're talking about the evaluation set. I'm not going to get into this yet. Actually, let's get into evaluation. Let's actually treat this like we're reviewing an actual like neural network and like what are the phases here. Let's start with the data gathering. I want to see how they actually get data. If they don't say it, that's fine. I don't think they actually. Let's see. Let's just go to the training data then. Actually, let's talk about the model architecture. Okay. So they pretty much did a very similar decoder only transformer architecture. So it's just it's and also it's autoregressive is pretty much what they're saying here. Um, they made several key improvements from Llama 2. Llama 3 uses a tokenizer with a vocabulary of 128,000 tokens that encodes languages much more efficiently, which leads to substantially improved model performance. Um, so that's a part of what I was saying, where like they have a very large feature space and they have a lot of data going through it, a lot of energy, and a lot of the data is it's very different. It's very I forgot the right way of saying it, but in data terms, but it's like there's it's very unique, I guess the different data items they have, the different data they have. Isn't it weird when people say data singularly? That has to be new. So they care a lot about inference, which is something Mark was talking about, because inference is anyone who makes money cares about inference. It went a little insight into the machine learning world and like people that make money building AI models and or ML whatever. Inference is who has to optimize inference more at whenever you go to an event or something like that, or you go to like that guy's the one who makes money. Okay, so they've adopted group query attention, which I believe I forgot what that was first used with, but that's like a fairly new thing. I mean, this is all within the year. I don't know when it was first thought of, but group query attention was something that I think I was only seeing like 6 months ago with these models. So they're using some pretty new concepts. Um, so they trained it. This is very important. They trained it on sequences of about 8,000 tokens. Okay, so they mask it, which is pretty normal. Okay, so let me see. I don't want to just go through everything. Okay, it's pre-trained on 15 trillion tokens, right? That's a lot of tokens. That's a lot. That's what I'm saying. Like, there's a lot of different cars going through those toll booths. Uh, our training data set is 7 times larger than the one they use for Llama 3. That's crazy. And it's also crazy that it's only 1 billion parameters more. And it has 4 times more code. Remember when I said, like, listen to what companies, the leaders say, because it's true. And it's like what they're actually doing. When Mark Zuckerberg said, we want to train these things on more code, like when we train LLMs on code, they get generally smarter. Of all the things you can say, if you say that, that probably means something. So they use 4 times more code. And I also think that's something to think about when you're fine tuning your own LLMs. To really think about, especially if you're fine tuning it to code, like what is my data set doing here, and maybe I can actually, maybe it's fine if I train it to code in different languages or something, because maybe it's learning something more general about reasoning, that can apply to my downstream task. Okay, so they have NSFW filters. They make it not cool, right? So that's one big thing here. They do guardrails. No one likes guys. The code llama is like pretty much not use. I can't use it for something I'm making right now, which sucks because it's actually very good. But I can't use it because, like, it sucks, but it's very good because it's always like saying that I'm a bad person because I'm a man, which is weird. I was like, how does it know that I'm a man? You know, like it literally said like you're a toxic man, and it said if I could, it's dude. I swear to God, Code Llama said if it could spit on me, it would, but it can't because it's an AI. I swear. Okay. Mark said that 13. The Jared, can you share any of your projects that you consider finished? I'm finishing one right now. I'm finishing one right now. I have a couple finished ones I can share. A lot of the GitHubs are, but I don't say which ones are finished and which aren't. So maybe I should go back and tag some as finished. Thank you for that. The one I'm making now kind of matters the most. So let me just finish that one. Okay, so human. Okay, so da 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 da. Okay, they developed a detailed list of scaling laws for downstream benchmark evaluations. So they determined some laws, very interesting, that enable us to select an optimal data mix and make informed decisions on how best to use our training compute. Importantly, scaling laws allow us to predict the performance of our largest models on key tasks. Okay, so what are these laws? Hold on a second. Oh, so this is interesting. So these are some new observations on scaling that they've learned. So while the chinchilla optimal amount of training compute, so the amount in which you can actually like the amount of compute you can use to actually like be effective in this context for an 8 billion parameter model corresponds to 200 billion tokens. So that's like the amount of energy they need. And we can talk about energy in terms of tokens. So that's like the amount they need. We found that model performance continues to improve even after the model is trained on 2 orders of magnitude more data. Guys, that's pretty fucking cool. But it's my first time reading this. That's cool. Okay, let me repeat that for a second. So, these are observations. While the chinchilla optimal amount of training compute, like the optimal amount, for an 8 billion parameter model corresponds to around 200 billion tokens. We found that model performance continues to improve even after the model is trained on 2 orders of magnitude more data. So I don't know if you kind of see what that's saying, but they don't know the asymptote. Like they don't like this hasn't reached a point where like they haven't gotten diminishing returns. Okay, like that's pretty interesting. That kind of means that's interesting That's kind of scary because it kind of just means that it makes sense why they bought so many GPUs because the only real answer to their problem is to just competitively is to just get more energy. Write better software, of course, which we'll get into the software piece of this, but they need more energy and they need, at the GPU level, they need better software and then they need better architecture at the math level. So there's like the math part, like the model architecture. How is like the math working? And then there's literally like, uh, do we write good software for the GPU? Because you cannot. Which someone was mentioning something GeoHot did, like some exploit he did. You guys know what it was recently? But something that I think it allowed for peer to peer GPU utilization. That's fucking cool. That's really cool, actually. Um, Maybe I only think that's just because I feel like I've talked to so many like people in this space, and I'll work for different companies and see what they need, and that's pretty crazy. That they so like and by the way, this aligns with something uh, Zuck the Cuck said. I don't know why I'm calling him Zuck. I actually like Mark. Um, it's just so easy to say, but but it's something he said where yeah they kind of realize like they can just keep adding data. It's kind of weird times we live in. Okay, so both our 8 billion and 70 billion parameter models continue to improve log linearly after. That's good. I don't know if you guys are CS people, but whenever someone says log linear, the senior engineer gets a boner. Okay, after we train them on up to 15 trillion tokens, larger models can match the performance of these smaller models with less training compute, but smaller models, are generally preferred because they're much more efficient during inference. Interesting. Remember, they care about inference. Big people who make money are optimizing inference. Okay, that's interesting though. So the larger models, with less, actually, I mean that's not that interesting. It has more parameters, so it has the capacity to learn more um, from the data in each pass. So that makes sense that it doesn't need as much data. That's not that interesting. But what's interesting is that they can just keep adding data. Though. All right, I don't know if I don't know if you guys can hear that. It's fucking this dude, the city man. Guess where I am right now? No, okay. I don't live here. Who is it? Where? Okay. All right. So they combine three types of parallelization: data parallelization, model parallelization, pipeline parallelization. Great. It's pretty normal in for someone at their size to do parallelization and a multi-tiered parallelization. Um, and then they're sort of adding different concepts here. I'm guessing. I'm actually curious if they use for model parallelization, if when they say that they actually mean they use like different experts. But I think they just mean traditionally. But that'd be cool if they did do mixture of experts here. Okay, so we perform training runs on two custom built 24K GPU clusters. Jeez, it's probably a lot. Jesus Christ. To maximize GPU uptime, we developed an advanced new training stack that automates error detection, handling, and maintenance. We also greatly improved our hardware reliability and detection mechanisms for silent data corruption. Nice. And we developed new scalable storage systems and reduced. Okay, now they're just saying, okay, that's cool. So all that stuff they did increased the training time 95%. So they did good. They did good. Okay, instruction fine tuning. This part is probably actually before we get into that, let's go back to the part I skipped. No, let's do benchmarks last. Let's do benchmarks last. Yeah. Let's just run through this. So we're going to talk about instruction fine tuning, and then we're going to talk about building with Llama 3. The benchmarking kind of cares more. We're going to skip the system level approach to responsibility. Uh, okay. All right. Because we don't care about that. Because we're 10x, so other people care about ethics. We don't care about ethics. Let's see. This is just Meta. Imagine the rest of the companies trying to do this shit. Well, what's cool is Meta has a ton of cash. That's what's cool. So because they have a ton of cash, they have a ton of energy. Because they have a ton of energy, the capacity for what they can do is greater. But also, the software always gets weaker when you get more energy. That's a little hint. Okay, so log linear is the wet dream of efficiency. Oh yeah, yeah. We don't care about ethics here because we're straight. All right, so guys, guys, I won't stop. I won't stop. I'll say it. I'll say it so you don't have to. Okay. All right. Let's see the benefit of being self-employed or unemployed. Guys, just quit your jobs. It's great. Um, let's see. Just met my twin. Nice. Let's see. He also said. By the way, I'm reading the chat right now. I'm just like saying stuff. Florian says. He also said intelligence really seems to be its own thing, completely detached from consciousness. Yeah, that's a weird thing. That doesn't maybe perceived intelligence. Dude, we should just have a stream where we talk about what is intelligence. Because that's a great question. Let's see. Only Meta and Microsoft has lots of GPU compute. I mean, no, that's not true. It's not only two companies that have a lot of GPU compute. Um, but yes, they have a lot. They have probably access to the most. Um, but like there's a lot of like I'm sure Google does, right? All right, so instruction fine tuning. Okay, to fully unlock the potential of our pre-trained models in chat use cases, we innovated on our approach to instruction tuning as well. Our approach to post training is a combination of post training is really like fine tuning. Okay, just to kind of I'm gonna explain some things. Uh, it doesn't need to be, but in this context, it is. Okay, supervised fine tuning. That's pretty much what I've been doing on the stream. That's the main thing I've done on the stream. I'm gonna do a deep. So they did rejection sampling, proximal policy optimization, PPO, and they did DPO, direct policy optimization. Guys, who's the person that said a month ago that DPO is like very important in the space? I have a by the way, it's not really just me saying that. One of my best buddies, who is might be in the chat, Tony, I don't know, is an AI researcher who's researching DPO, and it's clearly like uh, clearly RLHF was not optimal when it comes to like training these models to I'll just say to like reality to behave more human, and to sort of clearly having something embedded in the actual model is more optimal, especially now that things like ChatGPT or GPT-4 and these models that are open source can generate data sets really well. The average person can get by pretty well, I think, using DPO and things like that. Okay, I mean, like, there's still labeling involved. I'm not saying there isn't a human element. I'm just saying it helps a lot. Um, the quality of the prompts that are used in SFT and the preference rankings that are used in PPO and DPO has an outsized. I don't know PPO, by the way. Has an outsized influence on the performance of aligned models. Okay, yeah, I think that's pretty clear. Fine tuning works. Um, Oh, I mean, having good prompts for fine tuning works. Some of our biggest improvements in model quality came from carefully curating. By the way, if anyone's joining, I'm reviewing Meta Llama 3's like press release. Carefully curating this data and performing multiple rounds of QA on annotations provided by human annotators, of course. Like I said, there's always slaves involved. Listen, if you're trying to be great, you need slaves. Okay? Most of the Bible's talking about how to rear your slaves. Okay? So anyone who's against that, are you against God? I just got I just pissed a lot of people off with that. Obviously, all glory to God. Okay. I'm just playing around. All right. So consciousness. I'll get in the chat in a sec. Guys, also ask any questions in the chat. I'm gonna finish up this building part and then I'm gonna get into the chat and then we'll talk. And I want to get after I talk about what they're talking about here, I want to get into the benchmarks, and then Nate and I are gonna stream and we're gonna review your fucking resumes. By the way, if you want your resume to get reviewed, go contact post on my or Nate's Discord. I don't know if you have a link to. I mean, I don't know if you can put. I don't think you can post links in the chat. Oh shit, my thing is. Hold on. Need to charge. Okay, so let's talk about. So now they're talking about building with Llama 3 because that's what matters. All right. So their vision, what they say, is to enable developers to customize Llama 3 to support relevant use cases and to make it easier to adopt best practices and improve the open ecosystem. Uh, Sorry, whenever I hear like PR talk, it just makes me, it's like, okay, you're a good person. What do you want me to say? Like, am I supposed to read this and be critical? Like, yeah, you want to do good things. I'm kidding. You got to do PR, okay? All right. With this release, we're providing new trust and safety tools, including updated components on both Llama Guard 2 and CyberSec Eval 2, introduction of Code Shield. Okay. All right. The Code Shield, I already probably know. It's been so annoying dealing with the guardrails of Code Llama for the thing I'm doing. I hope when they say it filters insecure code, I think what they don't really mean security. Because I don't know if anyone's here is super into web security, but or just security in general. Most security issues are systematic. Okay, most codes they're gonna say, "Oh, we have to do these guardrails. We have to make it so you can't generate this code because you're gonna make a bomb." Guys, most security issues are not from like one generated fucking Python function. Okay, it's because you have an exploit. Now, what do we exploit? Any hackers here? What is if you're going to exploit something? What are you going to exploit? A system, something with layers. Okay, so when they say these things about like, and I get it, they're a big company. They have a lot of liability, so they do have to do this. But when we take their models and make them better, really keep in mind: are you really trying to make it safe? Okay, all right, so we've co-developed Llama 3 with TorchTune, the new PyTorch native library for easily authoring, fine-tuning, experimenting with LLMs. Nice. So that's nice. That's nice. The fact that, dude, PyTorch is so fucking good. Meta's, I'm shitting on them for the guardrails, but hey, they kind of have to do it. Uh, Go just use the bloke. Look up the bloke. Let me just the bloke. Get all your models from there. Uh, but the fact that Meta has like PyTorch is really cool. Um, all right, so yeah, okay, that part's fine. They have like a getting started guide for LangChain, and Llama 3. I'll have a video where I use Llama 3 without LangChain. I'm not a huge fan of LangChain. All right. So let's get into performance benchmarks. This is what we've been waiting. Oh yeah, let me get in the chat. Right. Let's see. Yeah, if you want your resume reviewed, post it on my Discord or Nate's Discord. It's gonna be a big one. It's gonna be we're gonna make fun of you. Just kidding. I'm not. No, no. Nate will make fun. I won't make fun of you. I'll be good cop. Nate will be bad cop. Okay, so chat's lit. Yeah, it's Jackaroo. I got a new cooler username. Jackaroo. I like how in the chat Jackaroo comes in saying, "I got a new cooler username, and it's $10 banana." Jackaroo, I might ban you. You're so excited that it's upsetting for something so stupid. No, it's endearing. It's endearing. Okay, so I did hacking for 1 year in the big. I don't even know what that means. Did you think before you speak? Sometimes you're commenting here, and I'll be reading people's comments, and I'm like, "Fuck, it's a deviant." I don't know if I should like. I need to read it first. Okay, I did hacking for 1 year, and the biggest pain you can cause as a hacker is getting into their database. True. Okay, so the bloke, our hero. Yeah, no, the bloke's the man. I'm trying to build a functional oriented alternative to LangChain. Now that would be JavaView. That would be very interesting. JavaView, are you interested in Lambda Calc? Let's see. Oh, Florian, hit me up when you're in NYC. Hit me and Jack up. All right. Cool, cool. All right. So let's talk about benchmarks. Let's talk about benchmarks. All right. So I'm just gonna go through the ones that they have here. There's a lot of benchmarks. A lot that I think is better actually than these. There's something that's valuable, maybe not better. These are actually the ones that I think are the most valuable. Um, Human eval is like, hold on a second. Oh, so this is the 8 billion one on the left, 70 billion one on the right. Before we look at these, I'm gonna go Google search because off the top of my head, I can like actually explain these, but I'll just cover what it's like trying to do. So MMLU is what is this one again? Right. Okay. So this is more of like in context understanding. So whether it can do tasks in the context of it. So they do zero shot and few shot settings. So they don't do any uh, prompt engineering or anything. They just say like, can it do multiple things on one essentially one pass, one prompt, and that's cool. And I think there's a lot of these. I don't know how many of these are there. There's a lot. There's a lot of these problems. So the multitask thing is interesting. So like that's really the main thing, and that's even something in I got to post Mark Zuckerberg's interview. Someone's got to remind me to put that in the description. I'm gonna fucking forget. But so one thing you did say is that that's still a problem. Having these LLMs, and not just MMLU, but just in general, solving complex problems, like problems that are like that aren't just to the nth degree, things that you will require more tools to do, and you need to do things and you need to keep the problem going. And then a new problem arises over time is difficult because time is hard. Time is a dimension that isn't really, we don't really like fully understand when it comes to problem solving. Um, I want to the best way to kind of like research that is like look into how people approach problem solving in business and how to predict um, forgot what it's called, but like when essentially when what are all of the possibilities of bad things happening when you make a decision? That's actually I think would help a lot when it comes to this. Okay, so GPQA. I actually don't know this one. So this is a Google Proof QA benchmark. So it's a data set. So these are multiple choice questions that are difficult by people that are pursuing PhDs. So really, it's just a very, these are things that you would need a lot of domain knowledge. So this is really like depth of knowledge. This is really GPQA is kind of like depth of knowledge. MMLU, multitask. GPQA is almost like the depth of its knowledge across categories, and that's low, right? So like, notice how MMLU is actually quite high because that's something they invest in because they care about reasoning. This isn't GPQA isn't really a reasoning benchmark, apparently. I might be wrong about that, but it appears to not be. It appears to be um, more so about in context. Can you figure out things that are, and obviously there's reasoning involved, but can you figure out things that would require a few steps of thinking, a few thought processes, but the information is sparse. So it's like you're never gonna have when you're training something on something like when you're evaluating on metrics when it has to do with depth. You're never gonna have it. The point is that you'll never have enough data to just throw more energy at it. So you have to solve it another way. And so this is a very cool benchmark. It's very cool. And human eval is famous. Let's get to the next one. Human eval is very famous. This is kind of the main coding one. This was the one that I think was made for Copilot. Let me just. I think I'm going to say it was. If I'm wrong, fine. Someone correct me if I'm wrong, but I believe this was made for Copilot. Um. Actually, I don't think it was. I don't think it was. I think Copilot used it, but I don't think it was. Anyway, but it doesn't matter. All right. But anyway, this is like the very common. It's just a list of like coding problems. Okay, let me actually get. I wonder if I can get an example. No, data. It's probably like a lot of shit here. Hold on a sec. It shouldn't be a lot though. Yeah, like for instance, this is the prompt. So this is the solution. So the prompt return one in Python, right? So in Python, define a function that's called return one. The solution is return one, and then they have a test, and they have this for a lot of different problems. So these LLMs are now trained uh, to be evaluated on this, and they're evaluated on it, and then they're trained on it. So this is really a good indicator of whether it can code good. Well, okay, GSMN 8K, GSM 8K. I already had to look this up for something. All right, it's a data set of 8.5K high quality, linguistically diverse grade school math word problems. Right, all right. Created by human writers. Okay, yeah, it's a math word problem. They take between 2 to 8 steps. So this is like a pretty big reasoning. So it's like arithmetic reasoning. That's kind of the main thing. Um, Mathematical reasoning. So that's important. And it looks like this one is crazy good at it. And it's so funny. As you saw, I already Google searched GSM 8K. It's mostly because I had to look it up for something. And I was reading it before and I was like, why does everything suck on it? And I was like looking at it, I'm like, this is like the most important thing. Can it solve a word problem? Because if you think about a word math problem, if you think about it, most of the problems we have coding really the type of the types of thinking is very similar to solving a word problem. And if like even if when you write pseudocode, you're kind of just solving a word problem. There's just no word problem. It's just like it's just something you have to make the word problem, then you have to like do the steps. So the fact that so this is pretty crazy. And I actually want to experiment with this now because none of none of these 7 billion parameter models are even close to being good at this. Probably because they don't have enough data to really reason well. So that's another thing with these models versus the big ones. The big ones are always just better at reason, like exponentially more. And I think it's just straight up they don't have enough energy. But what's crazy is Llama 3 does. The 8 billion parameter model does. They figured out a way to pass so much data. It's such a big feature space to this model while not getting diminishing returns. That's the most impressive thing they've done. All right, so let's go through the last benchmark here. We have math benchmark. I think this is another math word problem solving one. That I want to get a description of it. All right, well this is it. It's a math. It's another math word problem. I don't know the difference though, and it's good at it. It's good at it. You see the it's the same climb here. It's the same like these are bad at it. The other smaller models, open source model, Gamma and Mistral, and this is good at it, right? So it's kind of very similar to this. So I would say this is a very good sign of its problem solving ability. Um, and then these are it actually isn't better than Gemini at it, but that's fine because the 70 billion. The fact that the 70 billion parameter model is pretty much just as good and better at I would say like very important things like this GSM and MMLU. The fact that it's better at that than Gemini Pro is pretty impressive. Um, cool. And all right, cool. Those are the benchmarks. Those are the bench. Let's get into chat. What are you guys saying? What are you guys saying? Let's see. 2 plus 2 equals 4, but they don't know the formula is x plus y. Let's see. Uh, okay. I don't know. I actually don't know. Words with direct meaning are easy, but yes, exactly. Once ambiguity, tones, and attitudes are involved in words, that's when shit gets cutty. Well, also, it's English. So we've chosen the world language to be English, right? We've chosen Babel to be a language that has a lot of ambiguity in it, frankly, and not a lot of structure. And it's probably because it was developed, in my guess, through a lot of commerce, which is not structure. So, so that's interesting. So it's interesting that the intelligence framework we're building is using a language that is not fully clear. Like when it comes, like it's not mathematical, the language, but we're using math to give it more structure and make an engine that could use this really like non concrete structure. And also just like there's so many ways to use the structure of English. And we're using math to give it an incredible amount of structure and ability. And I don't know. I don't know if it's gonna work, but it might work. So far, it's working really well, but I don't know if like AGI is going to happen. But we'll see. We'll see. All right, guys. Any questions? How you guys doing? Like the setup? This is not a normal setup, obviously. I'm in a weird place. Let's see. Won't models always get this wrong since they are structured to pick a response that is of a lower probability? What do you mean they're structured to get something of a lower probability? Wait, get what wrong? Um, they're not really structured around getting lower probability, but I may also be misunderstanding what you're saying. Yeah, Meta has the edge with the data sets. Yeah, that's crazy. It's so crazy that Meta, like the advantage Meta has is so crazy. It's so nuts. It's so like when you actually think about it, it's crazy. But that's why I'm like the competing at the foundational model um level is like not really something that I'm interested in. Foundational models is mostly like, do you have enough energy? But well, also this a foundational model is more systematic. Like you just have a foundational model in your system. It doesn't need to be one of these, but the reason why I say it's them competing at the foundational models is because like who else is going to have that much energy to generalize that much? It's crazy. Meta is fascinating because they are very committed to open source, but also they're in an interesting situation because they've been doing AI for a very long time for a purpose that's like that's very inference heavy. I'd wager Google has the data advantage. I don't think so. Um, Only because I don't think Google's been using. I may be wrong, but I don't think they've been using ML at the extent in terms of like inference to the extent Meta has. I may be wrong. I may be wrong about that. Honestly, if they really want to build AGI, they will need a nuclear powered data center. Yeah, you know what's interesting? They're trying to get a data center that's a gigawatt. It's pretty nuts. Yeah, it's so fascinating. It's like how do you do this when in English? I feel like English is not the right language to do this on. I jumped in late, so might not get what you're saying, but here's what I mean. LM's temperature setting forces the LM to pick a response is less probable. You can set the temperature to zero, but I know what you're saying. I know what you're saying. In fact, you should. By the way, if you guys aren't setting your temperature to zero and you're trying to do anything that's like that involves a pipeline and things kind of if thenning, you should just set it to zero, honestly. But I know what you're saying. So the fact that it doesn't always do four is because of how neural networks work, though. It isn't so much because of the LLM. Two plus two doesn't equal four in the context of neural networks because like, they don't know anything that's truth. That's the truth. That's just the reality of how they work. They just don't. It's not like a truth engine. Um, like it's not. It doesn't know math really. And by the way, I understand it'll like probably get 4 99.999% of the time, but it's not actually it doesn't know that 2 plus 2 is equal to 4. Really, it just there's the likelihood is insane, you know. um Gmail web scraping, I bet Google, I think Google has raw data advantage for sure. But I don't know if they have data set advantage because I just don't know if they've been training models for this purpose for as long as Meta. Um, yeah, but you might be right. I mean, maybe I'm just like I'm being nice to Google right now because part of me is like maybe like they're so bad at what they're doing right now. Like they're so bad at competing with Meta that I'm like, maybe they just don't have the data sets. But they might just be a bad company. Um, Sequence analysis is not math. Yeah. Even CAS calculators can mess up. Yeah. Yeah. Well, there's also just a general floating point issue that hasn't been addressed. Well, it doesn't need to be because a lot of these LLMs are going to start making system calls in your OS for straight up. Watch out for that. That's gonna happen. And yeah, I don't know. Good luck when it comes to googling and I won't be using those. Now maybe I would. Maybe if it's good enough, I would. Human experience is also a hallucination. Uh someone's trying to fuck. That's what you say to all your philosophy students. Is that what you say to all the kids in your that you're tutoring for? Like, yeah, dude, human experience, it's hallucination. Doesn't mean anything. uh, you're touching my leg. It doesn't mean anything. It's a hallucination. I don't trust you. I'm just playing. I'm just making fun of you. All right. I gotta get off because I gotta go over to Nate's stream. All right. See you guys. You are not real. This is not real. All right. Will comes in. Will comes in at the last second, freaking out. All right, guys. See ya.